This video is going to cover the exercise for cross-section sheets for State Route 185. That's exercise 803 in the Ohio DOT Open Roads Designer Training. So I'm going to get started by creating some design files. So I'm going to open one of the files from my project. It really doesn't matter which one. I'm just going to use this as a launching point to create additional files. So with my design file open, I'm ready to create some new files. So from the workflows, I'm going to choose the Ohio DOT workflow, and we'll use the Ohio DOT Create Design Files application. Now I'm going to do things in a little bit different order than they're presented in the actual training material. So I'm going to start first by creating a design file for the prismoidal volumes. So I'm filtering by the roadway group. Oops, turn that back on. And I'm going to create a file for the digital terrain model, and I'm going to use that to contain the prismoidal volumes. So I'm going to go ahead and create the file, and after creating the file, the application is going to change to the file because in my settings I have Open Last Created File turned on. So it's asking me to check back in the current file in ProjectWise, so I'll do that. And then it's going to open that KD file that I'm going to use for the prismoidal volumes. So in this file I want to attach my models. So I'm going to go back to the Open Roads Modeling workflow and pick the References dialog, and I'm going to attach my corridor models. So under Roadway, Base Maps, I'm going to get all of the KM design files. And I'll go ahead and OK that to attach these three files. And on each of them, I'm going to not use any nesting. So I'm going to just accept the defaults here and attach all three files. And I'll go ahead and do a fit when that's done. Now I also need my survey information, so let's attach that as well. So we're going to get prismoidal volume differences between the existing and proposed. So on the 300 survey folder, under Base Maps, I'll bring that field book in as well. Now I can go ahead and make my terrain the active terrain by selecting that from the pop-up menu, choose Set as Active Terrain Model. Okay, so what I'm going to do is now use a command that's going to generate prismoidal volumes between the existing and proposed information. So the feature definitions that are assigned to each of the existing and proposed elements is what controls how it's computed in the earthwork quantities function here. So I'm going to go to the Home tab. Again, I'm still in Open Roads Modeling workflow. And under Civil Analysis, I'm going to run the Create Cut Fill Volumes command. Now it's asking me to confirm a feature definition for the cut areas and the fill areas. I'm just going to go ahead and accept the defaults there and continue just accepting the defaults. So let's take a look at what's been created here. So I have prismoidal volumes for the cut and fill areas. And I'm going to look at that in my 3D model. So if I hold down the right mouse button from View Control, I'll pick two views, Plan and 3D. And in the 3D model, I'll zoom in here. And I've got the model itself as well as these prismoidal volume areas defined. So we're going to use that when we cut our cross sections and get end area volumes by reading those prismoidal areas. And then those volumes will be computed in a report, and then those can be annotated on our cross sections. So that's the first step. That's actually under Part E of the training material, is creating that design file and putting our prismoidal volumes or computing our prismoidal volumes in that file. So now I'm going to create another design file for my cross-section sheets. So I'll go to the Ohio DOT workflow and pick the Create Design Files application and filter my category by roadway and by sheets. So I'm going to find the cross-section sheets file type and toggle that on. And I want to use the Design Seed 2D seed file, and I'm going to change this to a 5 scale. Actually, this really doesn't matter. It's just going to be the scale that's applied to the design model, but when I create the sheet models, we'll tell it to make them 5 scale or 10 scale. I will give this a description of our State Route 185 cross sections. So I'll go ahead and create that file. And again, in the settings, I still have Open the Last Created File turned on. So after the file is created, it's going to open that file, and ProjectWise will ask me to check the current file in to the server. So I'll go ahead and check that in. So this is in the Roadway Sheets folder under 400 Engineering. And I can close the dialog when that's complete. So now I'm going to go back to my Open Roads Modeling workflow, and from my Attach Tools, choose the References option. And we're going to attach all the information that we need to extract our cross sections, the information that we want to show on our cross sections. So I need to show my existing ground. So I'll start from 300 Survey Base Maps, pick the Fieldbook design file. I'll use the defaults here. Once that's attached, I will do a double tap on my mouse wheel to fit, zoom in with my mouse wheel, select the terrain model and make that the active terrain. And that creates a 3D model in my file and then attaches that 3D model to my current design model. I'm going to continue to attach references. So I need to get all of my files that have the corridor model information, all my 3D information. So I'll pick those 3 files and we'll attach those. Again, using no nesting or nest depth of 0 on these. I also need my center line, since I'll be running cross sections relative to a center line. So under Roadway Base Maps, I'm going to use the BK000 design file. And on this one, I should have changed the nest depth to, there we go, I'll change the nest depth to 1. Okay that. So I can see my center line is now available. Now anything that I want to show on the cross sections that is drawn in 3D, I would attach that. For example, if I had some 3D drainage defined, I would attach those files as well. I'm also going to attach the right-of-way and show you how to do 3D right-of-way and then right-of-way annotation in the cross sections. So I'll go ahead and attach that file. So again, under 400 Engineering, right-of-way base maps, I have a right-of-way file there. And I want no nesting on this one. If I had any underground utilities, like telephone lines or gas lines, I would also attach those files containing those 3D graphics. So I have the proper files attached. Before I start to extract cross sections, I do want to talk a little bit about the right-of-way and the requirements for that to show on the cross section. So I'm going to go ahead and save this file and save settings, and then I'm going to open that right-of-way base map. So under File, I'm going to pick the Browse button. It's asking me to check my current file back in. I'm sorry, not yet. I have to pick my file first. I'm a step ahead of myself. So under 400 Engineering, I'm going to go to Right-of-Way and Base Maps, and we'll open that Right-of-Way base map. And now it will ask me to check my current file back into ProjectWise. In order for the right-of-way to show up on the cross sections, the right-of-way lines need to be given an elevation. So I can see as I float my cursor over one of the elements with the pop-up there, it says it does not have an active profile. So what I need to do is define a profile. So I do have the survey information referenced. So with my element selection tool, I will select that terrain model and I will set that as the active terrain. With that active, what I want to do is apply the profile to my right-of-way lines by reading the existing ground terrain. So I'm going to do that in the Geometry tab. Under Profile Creation, there's an option to create a profile from surface or a quick profile from surface. The biggest difference is the profile from surface gives you additional things such as station ranges, and the quick profile from surface just just going to drape the element on the surface. So it's asking me to locate the reference element and then also a feature definition to be used for the profile. I'm not going to worry about that. So my reference element is going to be my right-of-way lines, and then pick the surface. And it's asking me locate reference surface reset to end, so I hit reset. So that should have applied a profile to this particular element. And I'm going to verify that by selecting the element from its pop-up menu, open the profile model, and I'll open the view and display the profile in that view. So I can see that I do have a ground profile along that element, and what I want to do is select that and then make that the active profile for that element. So now with that active, this element will show up in my cross sections. Let's take a look at this element in the 3D model. So I'll hold down my right mouse button, pick View Control, Two Views, Plan, and 3D. So in the 3D view, I can see that I have a 3D line string for that element, and the symbology for that is based on the feature definition that was defined for the right-of-way line itself. So this is the actual element that it's going to intersect and get its elevation. And in a cross-section mode, the cross-section, when it intersects that, it's going to actually place a cell that has that annotated. So you would do that for the rest of the right-of-way lines in the file. So I only have one defined relative to State Route 185, and that will be on the left side. So we should see that annotation come in when I cut cross sections. So I'm going to go ahead and go back to my cross section design file. And when I'm prompted, I'll check the right-of-way file back into the server. Okay, so now that I have everything prepared and ready to go, I need to do one more thing before I start extracting cross sections. I need to reference those prismoidal volumes. So for my references dialog, I'll add another reference. It says under 400 Engineering Roadway Base Maps, and that was a KD design file. So I'll go ahead and attach that. Now, I want to turn on or off the levels that I want to show on my cross sections, and that is done by turning on or off the levels in the 3D model. So in my view groups at the bottom, I have the design group and I have design 3D view group. So I'm going to open that design 3D view, double tap my mouse to do a fit, and now I can see all the elements that it's going to read in order to generate cross sections. So I'm going to turn off the things that I don't want to see in the cross sections. And some of these are things that you may not think of initially. For example, I've got a surveyed symbol for a tree, and that symbol is placed at the elevation it was surveyed at. It's 1004.693, I can see in the pop-up menu. If I happen to have a cross-section extracted right at that tree location, it's going to see that cell, and it's going to just draw a flat line representing the width of that cell. So even though this isn't a true quote 3D object, it is a cell that is placed in an elevation, and if one of my name boundaries for the cross section intersected that, it would show that. So I'm going to start by turning off levels. On my home tab, I'll pick level display. I'm going to go through each of these files and turn off the things I don't want to see. While on the field book file, I'm going to right click and turn everything off. The only thing I'm going to leave turned on is the ground line and the triangle model tin hull. So those need to be on in order for it to read the ground line and show the ground line on the cross sections. The rest of this information, I probably don't want to show it on the cross section. Now, you may have some things in here that you may decide you want to see, so you could turn those on, and if a name boundary happens to intersect it, it would show up. The 3D model, I'm probably okay to leave that as is. Mainly it's these surface meshes that we want to show in the cross section from our models. From our right-of-way, there's our right-of-way line, we want that, and the cut and fill volumes. Now these I don't actually want to show on the cross section, so I am going to turn those off. So once I have that defined, I'm going to save settings here and go back to the design model. Now, in order to lay out my name boundaries, I do need to display the 3D model. So I'll hold down the right mouse button. From View Control, I'll pick two views, plan and 3D. Now, it is important that when I'm in the multi-model view, turning off levels in the 3D model here is not going to impact the cross sections. It is actually going to that Design 3D view and turning on or off levels here that's going to impact the cross sections. So that multi-model view is just used to lay out my name boundaries. Before laying out the name boundaries, I'm going to choose the level for the name boundaries. So I'll type an S to go down to the S in my levels, and what I'm looking for is the sheet group of levels, and I'm going to pick the sheet name boundary level. So in my Open Road Modeling's workflow, I'm going to go to Drawing Production and pick the name boundary command. So I'm going to go ahead and extract the civil cross sections, and there are two different drawing seeds available. I'm going to use the 5 scale. And I'm creating a new group, and the start location is going to be based on selecting an alignment. So I'll put my cursor in the start location field and then come and pick my proposed alignment. So I'm going to start this one station before my actual corridor begins. So let's go to station 386. And I'm going to end this at station 428. The left and right offsets are set based on the detail scale and the drawing seed, so I'm going to leave those alone. Interval, I can change that if I'd like. I'm going to go with 50 feet. I'm not going to exaggerate the cross sections, and I have toggled on the top and bottom clearance and given them each a value of 10. Now I'm not going to create drawings here. I'm going to just lay out the name boundaries, and then I'll come back and create the drawings after I extract end areas from the prismoidal volumes. If I wanted to, I could also include control points, and it would add name boundaries at those control point locations. I'm going to go ahead and give a data point in my plan view that accepts the starting location. A second data point accepts the ending location. A third data point places the name boundaries in the file. So after the boundaries are created, they are displayed in the 3D model itself. So each of these boundaries could be modified if I needed to extend one to make it a little deeper or a little wider. I could do that. If I wanted to remove some, maybe I don't want some of the boundaries that are cut right through the center of this intersection. I could get rid of that one. If I needed to add additional ones, I'd go back to the name boundary tools and place a single name boundary at the location that I need. So the next step is to extract my end areas from the prismoidal volumes. So to do that, I'll go to the Home tab, and the Home tab under Civil Analysis, I'm going to pick the End Area Volumes report. This is going to ask me, do I want to associate some name boundaries with this? So from the list, I'm going to pick the name boundaries for my CLPS 185 group and accept that. And I'm going to go ahead and just reset to complete that selection and let it extract the end area volumes from the prismoidal volumes. So this is the end area volume report that's generated. And I can change the number of decimal places for this and the different parameters by just going to Tools and Format Options. So I want to change units to no decimal places and convert to cubic yards. So we'll go ahead and close that, and I'll see those settings are applied. So I can save the report if I'd like, just under File. You can save that wherever you'd like to save that. I'm just going to go ahead and close it. And what that has done is tagged each of these name boundaries with the end area cut and fill volumes. So I'm just going to come in here somewhere and just pick one. And if I look at the properties for that, it's under the civil properties. You can see the end area volume that's tagged on that. So if the design changed, I could regenerate those prismoidal volumes and then rerun the civil analysis command to generate the end areas, and that would update the tags that are assigned to each of these named boundaries. So at this point, I'm finally ready to clip some of my sheets. So I'll go back to the Drawing Production tab. And in the Name Boundary group, there's a little icon in the lower right corner. I'm going to click that icon. So it opens this Name Boundaries dialog. And under cross-section groups, I can see the group for the State Route 185 cross-sections. So what I'm going to do is turn on this option to show the Create dialog, and then click this option to create my cross-sections. So by turning on the option to show the Create dialog, I get this dialog, and I want that because I want to verify that the scale is set to 5 scale for the drawing model, and in the sheet model I want a 1:1 here and a 1:5 here. So I'll go ahead and hit OK and let it process the cross-section sheets. This is going to create a drawing model for each one of the name boundaries, and it's going to fit as many of those drawing models as it can on each sheet. After the processing is complete, the software leaves you on the last sheet, and I can see on this sheet that it was able to fit 2 cross-sections into the available area. So there are several models created with this process. Let's take a look at those models. So I'm going to look at the view groups list. In the view groups list, I can see the drawing models and sheet models that have been created. Let's take a look at the drawing model for station 386 plus 50. So the drawing model contains the annotation for the cross section. So I can see I have the grid lines, the profile, existing and proposed profile elevations and station labels annotated here, as well as offsets across the bottom and elevations on the side. It's also a table for the cut and fill volumes that are read from the prismoidal volumes and then the tagged name boundary areas. So this is in the drawing model, and the cross-section graphics are read from the 3D model itself. So if I go back to one of the sheet views, you can see this one, it was able to fit 3 sections on the sheet. And over to the left side, there is a name boundary element, and you do not want to delete these. You want to keep those in place. So even though they're kind of thrown off to the side, it can be a little annoying when you fit the view. You definitely want to keep those. So there is a table that can be used to put in the sheet totals, but at this time this table is not completed for you. So you'll have to take the individual cut and fill volumes and total those up manually and fill those in the table. So let's take a look at one of the cross sections that intersected that right-of-way line that I assigned an elevation to by giving it a profile. So in my view groups, I'm just going to come down to one of the later sections and go ahead and pick one of those. So I can see my existing right-of-way label that was generated. So whatever the offset is, I think it's 30 feet. Looks like it's 25 feet. It intersected that line, and then the profile elevation is read from the existing terrain. So this is just a label that's placed relative to that profile elevation, and that's part of the model annotation for the drawing model. So once I'm done clipping my cross sections, I'm going to go ahead and exit the file, and then I'll check the file back into ProjectWise. So that concludes this demonstration of the lab exercise for the State Route 185 plan and profile sheets.